Welcome to ThinkViL educational videos. In this video, we will learn about electronic configuration, covering their theory, key concepts, important formulas and practice questions. Now, let's understand, what is electronic configuration? Electronic configuration is the arrangement of electrons in the orbitals, or shells and subshells, of an atom. Each element has a unique electronic configuration based on the number of electrons it has, which equals the atomic number, the energy levels available in the atom, and rules that decide how electrons fill those levels. Now, let's understand the atom basic structure. First, understand that, what is an atom made of? An atom consists of two main parts. The first is nucleus, which is situated at the center of the atom, and contains protons with a positive charge and neutrons with no charge. And the second is electrons with negative charge, which move around the nucleus in specific energy levels called shells or orbits. Now, understand the electron shells or energy levels. Around nucleus, electrons do not just float randomly. They revolve in fixed circular paths called shells, also known as energy levels. These shells are labeled as K, L, M, N, O, P, Q, starting from the one closest to the nucleus, or numerically as N is equal to 1, 2, 3, 4, 5, 6, 7. Maximum number of electron in a shell can be calculated by using this formula, 2 multiplied n squared. Now, understand the subshells and orbitals. Shells are the main energy levels. Each shell contains one or more subshells. Each subshell is made up of orbitals. Each orbital can hold a maximum of 2 electrons. There are 4 types of subshells. The first is the s subshell, which has 1 orbitals and can hold up to 2 electrons. The second is the p subshell, which has 3 orbitals and can hold up to 6 electrons. The third is the d subshell, which has 5 orbitals and can hold up to 10 electrons. The fourth is the f subshell, which has 7 orbitals and can hold up to 14 electrons. Electron filling in orbitals follows certain rules and principles. Let's understand these principles. The first is the Aufbau principle. The Aufbau principle tells us the sequence in which electrons fill the orbitals of an atom. The Aufbau principle states that electrons fill atomic orbitals in order of increasing energy, starting from the lowest energy orbital available. There are some exceptions of this principle. For example, chromium, copper, molybdenum, silver, gold and some lanthanides and actinides. Now let's understand the Kleczkowski N plus L rule. The Kleczkowski N plus L rule, also known as the Madelung rule or the Aufbau principle in its extended form. The Kleczkowski N plus L rule states that electrons fill atomic orbitals in order of increasing sum of the principal quantum number, n, and the azimuthal, orbital, quantum number, l. If 2 orbitals have the same, n plus l, value, the orbital with the lower n is filled first. This is the Kleczkowski diagram, which shows the correct order for filling electrons in atomic orbitals according to the N plus L rule. These rules have some exceptions like chromium, copper, silver and gold. Now, understand the Pauli's exclusion principle. Each electron in an atom can be described by 4 quantum numbers: principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. Pauli's exclusion principle states that no 2 electrons in an atom can have the same set of all 4 quantum numbers. In simpler terms, an orbital can hold a maximum of 2 electrons, and they must have opposite spins. Now, understand the Hund's rule of maximum multiplicity. Hund's rule states that electrons will fill all orbitals of the same energy level, called degenerate orbitals, singly before pairing up. In simple terms, when we fill up orbitals of the same energy level, we first start filling electrons singly and then start pairing them up. Now, let's see the electronic configuration representation. This is the standard notation for electronic configuration, where this number represents the shell, these letters indicate the subshells, and these numbers show the electron count in each subshell. Let's take an example. What is the electronic configuration of iron? Let's understand the question with the help of the electronic configuration ThinkViL simulation. Now, open the ThinkViL electronic configuration simulation. Select the given element iron. This is the electronic configuration of iron, and this is the off-Bohr diagram, which shows how electrons fill the orbitals according to their energy levels. The electron filling in the orbitals follows the off-Bohr principle, Pauli exclusion principle, and Hund's rule. Here this is the Kleczkowski diagram, which shows the order in which electrons fill the orbitals. But there are some exceptions, like in copper, where an electron from the 4s orbital jumps into the 3d orbital for extra stability. This is the electronic configuration of copper. Thanks for watching the video. For access more educational resources, visit www.thinkvil.com. And don't forget to like, subscribe, share, and press the bell icon for more updates.